Hey guys, and welcome back. Let's go ahead and jump into our SSH server, or sorry, our Ubuntu server. We'll SSH into that server, and then we'll go ahead and generate some new user credentials here. And if you are looking for some good documentation, the Kubernetes documentation actually does cover this pretty well. So under the reference documentation here in the official Kubernetes documentation over at kubernetes.io, you've got the API access control section, and then within there's a bunch of different documents here that cover role-based access control and authorization and things like that. And it doesn't really have a logical title as far as I'm concerned, but there's actually a document here called certificate signing requests. And so this kind of covers how to generate a new private key and then use the public and private key of the actual master node in order to sign that key and give you a public key certificate that is then signed by the Kubernetes master, and that is ultimately what is going to give you access to the cluster. So anytime that you need to create a new user in the cluster, this is the process that you're going to follow in order to generate a key and then sign it with the master node's key, with the cluster key pair. And then once you've got that, we can then set up our context. So if you scroll down a little bit here, there is some documentation that talks about how to generate your certs. So let's see. So it's right here under normal user. And what we want to do is basically generate a new RSA key. So that's the very first step, is we're going to generate a private key. And we are also going to need to make sure that when we are generating our credentials, it's not really laid out here in the documentation, but when we actually sign the key, we need to make sure that we set the subject name of the certificate to have a common name of the user that we want to create, and then the O setting is going to be the groups that the user is going to belong to. So this particular example doesn't actually show how to set that, but we are going to do that once we sign the certificate. So for now, let's go ahead and just run the OpenSSL command to generate a new key. So let me head over to my SSH session here, and I'm going to go ahead and SSH into my new kubeadm launched cluster here. So I've got Amazon Web Services right here in front of me, and I've got a server that I spun up from a snapshot that contains kubeadm and a cluster pre-initialized. And what I'm going to do is just find the public IP address of my server here, and then we'll go ahead and SSH into it. So let's say SSH Ubuntu, and then I'm also going to add -o server alive interval equals 60. Just because I often get timeouts on my SSH connections. And then what we're going to do is just go ahead and, let's see, paste in our command here. Let's go ahead and find that command back over in the documentation. And then we'll paste that in. So that will generate a new 2048-bit key. And that's called myuser.key. I'm actually going to change this to a proper name just so it's easier to understand. So let's do move myuser.key to, let's say, joey.key. And then if we do ls-ll, you can see we've got joey.key right here. And now the next thing we need to do is to create a certificate signing request. So to create the certificate signing request, we are going to run the OpenSSL req command, specify the new parameter. Then we're going to specify the private key that we just generated right here for our user. And then the out file is actually going to be the file that's generated from this command will actually be a .csr file, which is short for certificate signing request. So this is just going to create the request for signing. It's not going to actually generate the public key for our user yet. Now there's one parameter that is missing from the documentation here, and that is the subject parameter that allows us to define the username and any groups that we want it to be a member of. So we're going to go ahead and add that. So let's go ahead and run the OpenSSL, and then we'll do req-new dash, and then we want the key parameter, and that's going to be joey.key, and then the out file is going to be joey.csr, and then we're also going to add in the subject parameter, So where is that? I don't see it, but I think we can go ahead and just add that here. We'll do subj, and then we'll do cn equals joey /o equals, and let's just put them in the databases group. And then I'll put a / right up here as well. And let's hit enter to run that. And so we should now have a CSR generated. So let's go ahead and do an ls-ll and just look at our files here. Now that we've got our CSR generated here in the joey.csr file, this is the file that we're now going to use in order to control the signing of our private key here, which is joey.key. So we're going to use OpenSSL again in order to sign that key. So if we head over to our documentation here, you can see that the way that they are generally working on this is actually to generate a certificate signing request as a resource in the cluster here. So typically what you would do is just send in that CSR using the resource here instead, and then you would actually use a kubectl command to approve that and then retrieve the signed certificate. But in this case, because we have direct access to the master node and we can actually access the public and private key for the cluster, we're going to go ahead and just use OpenSSL in order to sign it. So let's go ahead and do that now. Let's head over back into our terminal here, and we'll run the OpenSSL command. And then we're going to use the x509 subcommand here and add on the request parameter. And then our input file here is going to be the joey.csr file, our certificate signing request. And then we also need to pass in the public and private key for the cluster itself. So I'm actually going to put a hashtag here just to comment that out so it doesn't actually run. And if we head over to the etc Kubernetes directory here and then go under PKI, let me do ls-ll for long form. And now you can see in here we've got our ca.crt file as well as the ca.key file, which is the private key. So this public and private key pair are the actual cluster public and private key. And if you recall from the diagram that we were looking at initially right over here, this is how we are going to sign our private key over here for our user and generate a signed public key. So now that we know where those files are located, we can go ahead and bring back up our OpenSSL command right here. And then we'll go ahead and check out some of the other parameters. So we've got the CA key, that's going to be the private key. We've got the CA parameter here, which is the CA public key. And then we've also got the CA create serial parameter here, which doesn't take any input. It's basically just a parameter that allows the CA to generate a new serial number for our certificate. And then I think that's pretty much all we need to specify aside from days. We can set the expiration days here as well. And of course, we need to specify the out parameter here in order to specify where our certificate file should go. So let's go ahead and do CA create serial, and then we'll do CA, and that'll be etc Kubernetes /PKI/ca.crt, and then CA key is going to be etc Kubernetes PKI ca.key instead. And then we're also going to specify our out file. That'll be joey.crt, because this is our public key. That's going to be signed by the CA here. And then we're also going to specify the days, and we'll do days, let's just say maybe 1,000 days, so roughly 3 years, give or take. And I think those are all the parameters that we need to run this. So let's go ahead and hit enter here. And as you can see, it is complaining about being able to open the CA private key file here. And that is because the CA key is a private file, so we need to use sudo in order to gain access to that file. And we'll hit enter, and as you can see, it works as long as we have sudo there so that we get access to actually read the ca.key file, because that's a private file that most people should not be able to read unless they're an authorized administrator that has access to work on this Kubernetes cluster. All right, so now if we do ls-ll here, you should see we've got our key file, we've got our CSR file, and then we've finally got the signed CRT file. At this point, because we have signed the key, we no longer need the CSR file. So for cleanliness purposes, we can go ahead and just do rm joey.csr and clean that up. And we should be left with just our signed public key as well as our private key here. So now what we can do is take these credentials and actually create a kubeconfig file that defines our user credentials. And then once we've got that kubeconfig file created, we can start to access the cluster using these credentials. So we'll go ahead and create that kubeconfig in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.